We'll now be taking you through a demo of our convenient automated machine learning tool, or CAML for short.
I'll now be assuming the role of a data scientist trying to tackle the following classification problem. We'll start the application, open our local file directory and choose our dataset. In this case, I'll be choosing the Demo Titanic CSV. It's a tabular problem of classification, and I'll be needing auto clean and auto feature generation. We'll press next, and we'll be presented with all the statistics gathered for all the columns of the data. Now, I'll be using the data cleaning assistant to make sure that all the values that reach the model are logical and understandable by the model. Since it's impossible for this or any algorithm to perfectly correct all the data, I'll be leveraging my domain knowledge in this. We'll start with the passenger class, where it should be an ordinal list, and we will place the luxury based on comfort with the respective numbers down in the order list. This ensures that these numbers are understandable by the model. I'll also choose the fill method of fill with average. As for the name, it's obviously a nominal column, so we'll mark the nominal box and use the drop NA rows or drop empty rows for the fill method. Next, we have the sex. It'll be changed into a bool since it has only 2 values. And as a data scientist or as a domain expert, I would notice that the MAL is not a correct category, so I'll place it in the drop list for it to be replaced later on. Next, for the age, we'll just fill it with the average since most of the statistics look right. Now, we'll go to the fare. As for the fare, it's quite obvious that the -1 value is incorrect since the fare should be a positive number, so we'll readjust the minimum to be 0. Then we'll choose the fill method of KNN impute. For the tax, it obviously should be a float, so it will be replaced, and also update the minimum and maximum values of 0 and 100. Next, we have the port embarked, and again, as a data scientist or as a domain expert, I would know that XXX is not a valid entry, and I will be placing it in the drop list, and also choose the fill method of average. It is also a nominal column, so I'll be marking the nominal box. Survived, which is my output or my target, has only 2 values of 0 and 1, so I'll be making it a bool or a boolean. Now I'll be marking all my nominal columns, such as cabin, ticket, and that will be all for my nominal columns. I'll now have a quick look, make sure everything looks good, and I'll be pressing next.
After the completion of the feature extraction phase, we now set the user preferences for the hyperparameter optimization and neural architecture generation module. We set the experiment title to experiment 1. We set the minimum and maximum values for the learning rate in a log uniform sampling space. We set the range for the number of fully connected layers to be between 3 and 5, and sample between that range in a random manner. We also provide a list for the maximum number of neurons per layer, and sample at that also at random. As for the batch size, we will limit the search space by providing only a constant value of 2. In the search algorithms, we will choose Bayesian optimization. For the number of trials, we will choose 21. For the CPUs per trial field, we'll leave it empty to use the default value for that. As for the GPUs, we'll be using only one GPU that is available on the machine. We will choose the output directory, in which we will expect our final output in, and then we will wait a while till the first neural network training is done and we load the best network. As we can see, the networks presented on the interface are truncated for values over 20 in the layer size. The real values for the layer size could be found in the header above the network. This process was sped up to fit into the demo video, and it took exactly 2 hours and 37 minutes. And finally, you can find the output files in the output directory we previously set. Thank you for using CAML.